Good evening all. Today we are going to learn about the numericals which is given in NCERT textbook in page number 160. Okay, so 1 to 6 questions are MCQs that you can practice, and from question number 7 all the numericals based on mirrors and lenses which have been given, that I'll explain you, and which are very important, and that how to solve the numericals. I will make you very clearly understanding these numericals. Okay, so listen and note down also. So let us see the first question which is given in page number 160, all the back exercise questions. We wish to obtain erect image. Erect means we know that it is straight. Of and mirror, which mirror is given? Concave mirror. Concave mirror forms real images and virtual images. So real images are inverted, virtual images are erect. That you will know already. So the same thing is also asking, using concave mirror, when do we get the erect image? The condition is when object placed between pole and focus point. So here if you place the object, you get the image, erect image. So this is what the answer. Okay, but let us try to understand the question properly. Concave mirror whose focal length is 15 centimeter. Focal length is given. What is focal length? Focal length is nothing but the distance between pole to focus is called as focal length. What should be the range of the distance of object from mirror? Okay, so he is asking what should be the range of a distance of the object. What is the object distance? So here focal length is given, and what should be the range of distance of object from mirror? What is the nature of image? Is the image larger or smaller than object? Draw the ray diagram. Very simple, very easy question. So okay, so let us try to understand it. So first I will draw the concave mirror. Concave mirror. Okay, principal axis. The same diagram. Pole, focus point. Okay, and center of curvature. So what is given here? Concave mirror of focal length 15 centimeter. So focal length is nothing but the distance from pole to focus is known as focal length. So if I take this distance as 0, and here it will be 15 centimeter. So where should I keep to get the erect image? I should keep the object between pole and focus. Anywhere which should be 0 to 15 in between. If you keep here, you will get the erect image. If you place the object here, you will get the erect image. So wherever the object, to get the erect image, where will we keep the object between pole and focus point? So if I draw the diagram, let me consider C also. So parallel, after reflection passes through focus point, right? Now I will take another light ray which passes from center of curvature, reflects in the same line, same direction, and if I extend these two light rays, they will meet at a point and where I get a image of the object. So this is what the answer. So now you observe what should be the range of the distance of object. Object should be, the range will be, range of object should be placed between 0 to 15 centimeter. And where should we place it? We should place between pole and focus point. And what is the nature of image? Nature, if you see, nature is erect image. Nature is erect. And which type of image it is? It is a virtual image. And if you observe the size of the object and size of the image looks bigger than the object. So is image larger or smaller than object? Yes, image is larger than object. Larger than object. So this is the nature of the image. Understood? I hope you have understood, and this is the diagram for the question number 7. Please note down. Okay. Let us see the next question. Ninth one. one half of a convex lens, one half means half part of the full lens. Convex lens is covered with a black paper. Okay, I will draw the diagram. We know that this is a convex lens. Okay, and optic center, principal axis. Oh, so okay, above the line, above the principal axis is half part, and below the principal axis is half part of the lens. So one half of a convex lens is covered with a black paper. Consider that. Imagine that I have covered it with a black paper. Okay, just let us assume it as a black paper. One half is covered with a black paper. Will this lens produce a complete image of the object? If I pass the light rays, imagine that I have passed the light rays to get the image. Imagine that this is a object I have placed, and I will get the image right side. So let us consider two light rays. Okay, and object passes through, focus point parallel, right? So this is optic center P, F1, and let us assume this as C1. So image forms at C1, or anywhere. You have not mandated that object is at C1 because it is not mentioned there. Okay, so I have placed the object here, and this will be F2, and here will be C2. Okay, fine. Now to get the image, another light ray. Consider that. Imagine that another light ray is passing through the optic center. Another light ray is passing through optic center, and let us assume that, imagine that both the light rays will meet at this point. Okay, so here I will get the image. This is the image of the object. Okay, so if you use scale and draw it properly, you will get the correct diagram. So now the question is, so here, okay, no problem for the object, the above side, this arrow will form a clear image. Then what about this shaded part? What about that? Suppose imagine that the light ray consider that which is passing from this end, this end. So what about this image? Will it forms image? Lens produce a complete image? That is the question. Yes, produce a complete image. Even though you cover with a black paper forms the shadow of the object. So image will appear dark in color, but image, this half portion is not covered, it is transparent, so it forms a clear image, but half of the other half portion will be also formed, but it is not clear. So that is why what answer experimentally, this is like the diagram if we draw it. So what can be the answer? Answer, yes, it forms a complete image, but the intensity means the brightness, the capacity of the image, the intensity is very low. The intensity of image is very low. I hope you have understood. Okay, this is a important question. One more question, another question also can be framed. I'll explain you. Let us consider this as a convex lens, okay? And here what I'll do is, I'll divide this convex lens into 5 parts. 5 parts I have divided. So I'll just draw the different patterns, different shapes. Okay, so different patterns. The lens I have divided into 5 parts. Okay. Okay, this is another shape, another structure, and imagine that this is different structure. Now the question is, when a light ray passes through this lens, how many number of images will be formed? That is the question. When we pass the light rays from this lens, this transparent lens, number of images formed through the lens. How many? If you see one structure, different structure, 2, 3, 4 and 5. So how many number of number of images formed are 5 images. Okay, this is also very important question that you should remember. Suppose if I divide into only two parts. Imagine that convex lens. So how many images will form? 2. Understood? Okay, so this is also one of the important questions that you should remember. Let us see the next question. Okay, let us let us see another question. An object of, this is the 10th question, okay, an object of 5 centimeter in length is held 25 centimeter away from converging lens. Okay, this is very important. Converging lens, as I told you, convex lens is also known as converging lens, and concave lens are also known as diverging lens. Converge means meet. Okay, so when light ray passes through convex lens, what happens? They will meet. Okay, they will meet. That is called converging. Okay, light rays actually meet at a point. So converging lens means what? Which diagram we need to consider? Convex lens. Okay, of focal length 10 centimeter. Okay, so see here, object 5 centimeter in length. It means object height h0 is given. H0 is equals to 5 centimeter, and it is held at 25 centimeter away from the lens. It means that object distance is given how much? 25 centimeter. Okay, 25 centimeter minus, and also the focal length f is given for convex focal length positive. So 10 centimeter. These are the values which is given in the question. Draw the ray diagram. He is saying to draw the ray diagram using these values. Suppose if you try to draw the ray diagram, I got the ruler also, scale. Height of object, okay, I will draw 5 centimeter. This is the height of the object using a scale, 5 centimeter. And here suppose imagine that you have drawn a converging lens, and this object from lens to lens will take from midpoint, from optic center. All the distances will measure from the optic center. Okay. So from here to 25 centimeters, see 20 is a 30 centimeter scale, 25 centimeter. So I need to place the object here. Now it is possible for me because I have a board, big long board. But when you draw in the book is smaller. Okay. So how can you draw? So using these the length is more here, which is given in the question. Length is more. So what I will do is I will consider this 5 centimeter. I will consider this 5 centimeter as 1 centimeter. Okay, 1 centimeter. It means 1 is nothing but 5 here. I have just considered to draw the ray diagram, but at the end, what I will do, I will multiply. And 25 centimeter, I will consider it as 5 centimeter. And 10 centimeter, I will consider it as 2 centimeter. Understood? So instead of taking this big long value, like the length will be more, so bigger value. So what I have done is 5 centimeter. I am considering it as 1 centimeter. 25, 5 and 10, 2. Understood? So taking these values, we will draw the diagram. Then we will convert it into, like we will multiply. So first one. So I am considering 5 as 1 centimeter, 25 as 5 centimeter, and 10 centimeter as 2 centimeter. Okay. So let me draw the lens. Converging lens, convex lens. Okay. Optic center, and I'll draw principal axis. Okay, so here you need to take measurements also. So what is the object? 5 centimeter height, and how much distance? 25. So 25 what I did, I have considered as a 5 centimeter. So what I will do is, from pole to, the same thing you can even draw in your book also. So from pole to 5 centimeter. Okay, from pole to 5 centimeter. Understood? Same thing you should draw in your book also. From pole to 5 centimeter, I will draw the object. Understood? See, here actually 5 centimeter I will get here only. But you take this measurement. Consider 5. Even the height of the object, you should draw how much? 1 centimeter. But here it is more than that, because otherwise it will not be visible. So here, what is the height of object? It is 1 centimeter only. Same scale you draw in your book also. Now, and so here, if it is a optic center, this will be the focus point. So what is focal length? Focal length is nothing but the distance from pole to, or from optic center to focus point. Okay. So let us consider this as f1. And here, so how much distance that we should take? f2p 5 centimeter, f2p 10 centimeter, na? So 10 centimeter, what you do? You will take it as 2 centimeter only. So here, like 2 centimeter. Okay, in your book. So the distance from focal length, okay, focus point, and let us assume this as AB. Image is AB, and here I will draw 2 centimeter right side. Okay, f2. Okay. So what? See now, from here to the object. Na, this is the object. From here to here. From here to here, what will be the distance? Object distance u is equals to how much? 5 centimeter. Understood? And this height of the object how much? 1 centimeter. 1 centimeter, here 1 centimeter, but actually it is 5 centimeter. Okay, here it is 5 centimeter, but actually it is 25 centimeter. If I draw here, it is okay, it is fine. But when you draw in the book, this will, like, the space is not sufficient. The book is small and the length is very big, the long. So now, so what will be the distance f2 focal length? It will be 2 centimeter. I hope you have understood. Clear? Now, so to get the image, the converging lens, I will take one light ray parallel. So what happens? It will pass through. Okay, it will pass through focus point f2. Okay, up to here it is 2 centimeter. Another light ray. Okay, here you are getting the image. If you measure both the lengths, so both the length here and measure, it is 1 centimeter, na? It will be less than that. Okay, you try, you measure it. When you take these scale, like 5 centimeter, if you take 1 centimeter, 25 centimeter as 5 centimeter, focal length 10 centimeter as 2 centimeter, the height of image will be 0.7 centimeter. You try it in the class, in your notebook. Okay, so it is 1 centimeter, it is 0.7 centimeter. Now draw the ray diagram and find the position size and nature of image formed. Now tell me nature of image. First I will start with nature. Where is the position? Position will be right side, or in the direction of the incident rays, in the direction of the light rays. That is the position of the image. And how it is? It is which image? It is a real image. It is inverted. Okay, and tell me the height here 1 centimeter. It is 0.7 centimeter. So what will be the size? Size will be diminished, real, inverted, diminished. So these are the these are the and to get the position. Suppose if you want to get the position, you measure from here to here. From here to here, measure the distance. What is the distance? Here it is, object is at 25 centimeter, 5 means 25, and you measure this distance, you will get it. Okay, you draw and you try. If you don't understand, you mention in a comment box. Okay, so what I mean to say is, here 5 centimeter, 25 centimeter, 10 centimeter, the scale is given. Instead of 5 object, you take 1 centimeter. Instead of 25 centimeter, from object to lens, you take as 5 centimeter. Okay, convex lens. And then focal, away from the focal length is given 10 centimeter here. So focal length is nothing but optic center to focus point. So this distance, okay, and this distance here from here to here it is 2 centimeter. Take it as a 2 centimeter. 2 centimeter is equal to 10 here. Okay, by taking this scale, you try to meet the light rays, you will get the image. After getting the image here, you measure this distance from here to here. Here to here it is 25. 5 is nothing but 25. Here to here 25 centimeter, and here to here what is the distance? That position you write down. Position is nothing but the distance of image distance. You write down whatever the value you will get, and then it is a real image, inverted, and here 0.7, here 1 centimeter. It is a diminished. So if it is a 5 centimeter, suppose if I take it 5 centimeter, which is given, I got it 0.7 image. 0.7 into 5 multiply. 7 5 is a 35. 0 5 0 is 3. So 3.5 centimeter. Here 5 is 3.5. It is also diminished only, smaller image. Understood? Okay, try this. Let us see the next question. Okay, let us see the 11th question. A concave lens is also known as diverging lens, of focal length 15 centimeter. Focal length value is given 15 centimeter. So f is equals to 15. I told you convex lens and concave lens, the sign conventions. One video I have made, concave lens and convex lens. Convex, right? So U is common, negative in both mirrors and lenses. It will be negative. Object distance is minus. Convex, if you see the last letter, if you just turn it, x will become plus. So in convex lens, everything is positive. F positive, V positive. Concave, I told you again, if you write the word negative, the last two letters are VE. Here also VE, negative. So F minus and V minus. Understood? So in this way. So now which lens is given? Concave lens. Concave lens is all minus. So F is equals to minus, and forms an image 10 centimeter from the lens. So image distance is also given 10 centimeter. Now 10 plus or minus, minus y, concave lens minus. And how far is the object placed from the lens? So what is he asking? He is asking find the U value. What is the lens formula? 1 by F is equals to 1 by V minus 1 by U. Substitute all the values. Minus 1 by 15 is equals to minus 1 by 10 minus 1 by U. So V value minus 10. Okay. Now I have to find U value. So I will keep minus U, 1 by U this side, and I will send 1 by 10 to another side. So minus 1 divided by U is equals to, if minus 1 by 10 goes to another side, it will become positive. So minus 1 by 15, I am not changing the position of 15, I am just keeping it here. I am just sending 10 out to another side. So minus 1 by 10 will become plus 1 by 10. So minus 1 by U is equals to LCM. If you take 15 comma 10, 5 3s are 15, 5 2s are 10. So 5 3s are 15, 15 2s are 30. 30 LCM. 15 1s are 15 2s are 30. 2 into 1, 2. So here you have minus, so minus 2. Positive sign. 10 1s are 10 3s are 30. 3 into 1, 3. So minus 1 by U is equals to 1 divided by 13. So U is equals to minus 30 centimeter. This is the object distance. Okay, so object, how far the object should be placed? Object should be placed 30 centimeter from the concave lens, so that focal length, image, where do we get the image? At 10 centimeter from the lens. Okay, so using these values, we need to draw the ray diagram. Okay, for which lens? Concave lens. Okay, now see here, u value we got it 30 centimeter. Okay, and v value 10 centimeter, and focal length is given 15 centimeter. Now, using this 30 centimeter, 15 centimeter, it's not possible in a small book. Okay, so what I'll do, I'll consider these values. Okay, I'll consider these values as with different values. So what you'll get is, you'll get again same, like multiply it, then you'll get the actual size of the image. Okay, so I'll draw the ray diagram. Okay, so what I will do is, I will consider object distance 30 centimeter as 6 centimeter. Okay, because it is possible, taking these values in the book. Okay, 10 centimeter as 2 centimeter and 15 centimeter as 3 centimeter. Okay, these are the measurements. Using these measurements, draw the diagram. First, I'll draw the concave lens. Okay, optic center, principal axis. Fine. Now, object, where should I place object? Object from optic center to from here to 6 centimeter. From this point to 6 centimeter. Let us assume that this is a 6 centimeter. From here to here 6 centimeter. 6 centimeter is nothing but 30 centimeter. Okay. So I have placed the object here. Okay. This is the object distance u6. In bracket you can write down 30 centimeter. Okay. And now, what is the focus point, focal length, 3 centimeter. 3 is nothing but 15. So here I will take it as f1. So what this will be the, how much distance? 2 centimeter. 2 centimeter is nothing but 15. 3 centimeter. 3 centimeter is nothing but 15 centimeter here. So now let us consider the light rays. One light ray parallel. So what happened? This is a diverging lens. When the light ray enter, the light ray diverge away from the lens. Okay, and it appears to pass through focus point. Okay, it appears to pass through focus point. Okay, another light ray. Let us consider another light ray. It is passing through optic center. Use scale while drawing the ray diagram, and arrows are must. And what happens? Where do we get the image? Image will be formed at this point, and this is the position of the image, which is virtual. So image distance how much? 2 centimeter. Okay, 2 centimeter is nothing but here. This will be the image distance 2 centimeter. I hope you have understood. So what I did, instead of taking 30 centimeter, I took 6 centimeter. So from here to here, actually it is 30, but I took it as a 6 centimeter. 6 is nothing but 30. And focus point, it should be how much? 15 focal length. But what I did, I took from here to here 3 centimeter. And then I consider a light ray parallel, appears through, pass to focus, optic center, will travel straight. So both the light rays are meeting at this point. Here we will get the image. And what is the image distance? 2 centimeter. From here to here 2 centimeters, but actually 10 centimeter. Understood? So this is the answer for 11th question. Okay, let us see the next question. Let us see the 12th question. An object is placed at a distance of 10 centimeter from which mirror is given? Convex mirror. Okay. So convex mirror, I told you the sign convention. Convex, last letter X. If you turn it, it will become plus. So except U in mirror, I am talking about convex mirror. Convex mirror, except U, all the values, all the like image distance, focus, focal length, everything will be positive. So U is negative, V plus and F also plus. Okay. Now object is placed at a distance of 10 centimeters. So he is given object distance U is equals to 10 centimeters. So U is negative, common for both objects and lens. And convex mirror of focal length. Focal length is given how much? 15 centimeter, and focal length will be plus. Find the position and nature of the image. So image we need to find using the mirror formula. What is the mirror formula? 1 by F is equals to 1 by V plus 1 by U. So 1 by F, 1 by 15 is equals to 1 by V minus 1 by 10. So 1 by V, send this minus 10 to another side. 1 by 15 minus 10, if it goes to another end, it will become positive. What will be the LCM? Already I read 15 comma 10. 5 3s are 15, 5 2s are 10. 5 3s are 15, 15 2s are 30. LCM is 30. 15 1s are 15 2s are 2 into 1 2 plus 10 1s are 10 3s are 3 into 1 3. So what is the answer? 1 by V is equals to 3 plus 2 5 divided by 30. 5 1s are 5 6 are 30. So 1 by V is equals to 1 by 6. Therefore V is equals to 6 centimeter. Units we should write. Sometimes we forget it, but it is very important. Otherwise there is a chance to lose the marks. So units also you should write. If it is given in centimeter, you should write in centimeter. If meters, then meter. So find the position of image. Image position is 6 centimeter, and nature, very simple to write the nature because it's a convex mirror. So convex mirror, what will be the nature? It always form virtual image and erect image. Okay, virtual, erect. If you want to know the magnification also, what is the formula? M is equals to V by U. Okay, magnification. What is V value? 6. What is U value? 10. You get the magnification minus 10. You get the magnification also. You can say it is a smaller image or bigger image. So you will get it smaller only. Why? Convex mirror always form virtual, erect and diminished images. Diminished. You even while using the formula also you will get the smaller image only. So minus 6 by 10, if you solve in two table and if you divide, you will get a smaller image. So this is the nature of the image. This is answer for 12. Let us see next question, 13th one. Okay, let us see the next question. 13th question is magnification of a plane mirror is +1. What does it mean? As I told you already, if magnification is greater than 1, image will be enlarged image. If magnification is equals to 1, same size, image will be the same size of object size and image size is equal. If magnification value, if you are getting less than 1, image will be smaller in size, we call it as a diminished. So what is given here? Plane mirror is +1, it means which is equals to 1. So what will be the answer for 13th one? 13th answer, the image size is equal to object size. This is the meaning of the question. Both object size and image size is equal. Okay, next question. Next is 14th question. The question is, an object of 5 centimeter in length. 5 centimeter in length, it means object H0 is equals to 5 centimeter, object height. placed at a distance of 20 centimeter in front of a convex mirror. This is very important. Convex mirror, and that object is placed how much distance? 20 centimeter. So U value is equals to minus 20 centimeter. And where did it placed? Convex mirror. Convex mirror, I told you, except U, all the image distance, focal length, and radius of curvature, everything is positive. R is given radius of curvature 30 centimeter. So what we need to find the position of image distance, and nature of the image also, and size of the image. So to find V value, we know the mirror formula. We should know the F, but F is not given. So we know the formula. R is equals to 2 times of focal length. F is equals to R divided by 2, which is equals to 30 divided by 2 is equals to 15 centimeters. This is the F value. Substituting the formula, 1 by F is equals to 1 by V plus 1 by U. What is F value here? 1 divided by 15 is equals to 1 by V minus 1 divided by 20. Send this minus 20 to another side. 1 by V is equals to 1 by 15 plus 1 divided by 20. Take LCM. 15 comma 20. 5 3s are 15. 5 4s are 20. So 5 3s are 15. 15 4s are 60. 60 is the LCM. 1 by V is equals to 15 1s are 15 4s are. 4 into 1 4 plus 20 1s are 23s are. 3 into 1 3. So 1 by V is equals to 7 divided by 60. V is equals to 60 divided by 7. If you solve, if you divide it, 7 8s are 56, 4.0, okay, 7 8s are 56, 7, okay, 7 5s are 35, okay, 7 7s are 49. So V is equals to 8.57 centimeter. Object is 20 centimeter and image distance is 8.57 centimeter. That is the image distance. Now what we have to find? We need to find the nature and size of the image. So to know the magnification, to know the size, we know the formula. What is the formula? M is equals to Hi by H naught is equals to minus V by U in case of mirrors. In case of lens it is plus V by U. So M is equals to, what is Hi? Hi is not given, we have to find Hi divided by, what is H naught? 5 is equals to, what is V value? Minus 8.5, 8.5 I will take it as 8.6 divided by 8.57, okay. And next V value minus 20. So Hi divided by 5 is equals to, minus minus get cancelled. So 8.6 divided by 20, 2 4s are 8, okay, or you can directly cancel here also. 8.6, 5 1s are 5 4s are 20, 4 1s are 2 2s are 4, 2 4s are 8, 2 3s are 6. So Hi is equals to 4.3 divided by 2, 2 1s are 2 2s are 4, point 2 1s are 2, 10, 2 5s are 10. Hi is equals to 2.15 centimeter. As object height is 5 centimeter, image height is 2.15 centimeter. It means the image is, the size image is diminished. Image is diminished, and nature, which mirror it is? It is convex mirror. Okay. So convex mirror, as we know, everything will be positive. That is the reason F is positive, V also positive. We got the positive answers. So it forms virtual image, diminished already I have written, and erect image. This is the answer for 14th question. Okay, let us see the next question. Next question, 15th question. Very big question. It is similar to the previous problem, but only the mirror is different. Here it is given concave mirror. The previous one is convex. Okay, so let me write the given values first. An object of size 7 centimeter. What does it mean? height of object 7 centimeter is given, is placed at 27 centimeter in front of concave mirror. U value 27 centimeter, which is minus negative. Of focal length 18 centimeter. Focal length f is equals to 18 centimeter and it is a concave mirror. So focal length will be negative minus. At what distance from the mirror should a screen be placed so that a sharp focused image can be obtained? Find the size and nature of image. So at what distance the screen should be placed? Why do we place the screen? To get the image. So he is asking to find V value. Also he is asking to find size. Size means magnification and nature of the image. Nature of image. So these are the values which he is asking, which we have to find now. Okay. So whenever the problems are given, first we should see which mirror it is and the sign conventions. So to find V value, formula, mirror formula, it is given concave mirror 1 by f is equals to 1 by v plus 1 divided by u. What is f value? Minus 1 divided by 18 is equals to 1 divided by v minus 1 divided by 27. So we need to find v value. Send minus 27 to another side. 1 by v is equals to minus 1 divided by 18 plus 1 divided by 27. Okay. Now take the LCM. 1 by v is equals to 18 comma 27 LCM. 9 ones are 9, 9 twos are 18, 9 threes are 27. So 9 twos are 8, 9 threes are 27, 27 twos are 54. Okay. 9 threes are 27, 27 twos are 54. Okay. So write 54 here. So 18 table, 18 ones are 18, 18 threes are 54. So 3 into 1, 3, minus 3, plus 27 ones are 27 twos are 54. So 2 into 1, 2. So 1 divided by v is equals to minus 1 by 54. Therefore v is equals to minus 54 centimeter. So object distance is minus 27 and v is minus 54 centimeter. As it is a concave mirror, so image distance will be minus. Okay, and sometimes it will be positive also, because in one case we will get the virtual image. Okay, fine. Now what we need to find? We have to find magnification. As height of object is given, then substitute in the formula. M is equals to Hi divided by H naught, which is equals to minus V by U. Okay, so what is Hi value? Hi divided by, we have to find it, H naught 7, which is equals to minus V value 54, minus 54, minus of minus 54 divided by U value how much? Minus 27. Minus minus get cancelled. So Hi is equals to 27 ones are 27 twos are. Okay, so Hi divided by 2 is equals to minus, so Hi divided by 7 is equals to minus 2. Therefore Hi is equals to minus 14 centimeter. So height of object is 7, height of image is double to that, double of the object. So it means that image is longer in size. So what will be the size of the image? We will write it as enlarged. Size is enlarged. And which mirror it is? Concave mirror. So in concave mirror, enlarged image found beyond C. So it means it is a real image. Okay. Between F and C, beyond image and no, wait. Yes. Height of image is minus, na? So minus means down. Real image and inverted. Inverted, real and enlarged are magnified, both the same. This is the answer for 15th question. Okay, let us see the next question. Let us see the next question, 16th question. Find the focal length of lens of power -2 diopters. Diopter, power is measured in diopters, SI unit of power is diopter. What type of lens is this? See, value, the power value is given. Power is given 2 diopters, which is having minus symbol in front of the value. So, very simple technique to remember. As I told you, convex, the last letter is X. If you turn it plus. Let us see the last two questions. 16th question. Find the focal length. Find the focal length of power -2 diopters. What type of lens is this? The question is, find the focal length. We need to find the focal length. Power is given. So power is measured in diopters. SI unit of power is diopters. Okay, and he is asking to find the focal length. What is the formula? Power is equals to 1 divided by F. Reciprocal of focal length is known as power. Okay, so power value is given -2 is equals to 1 by F. A simple technique I will tell you. When the power is minus, okay, when power is minus, as you all know, the types of lenses, two lenses, convex and concave. Convex, last letter X, if you turn it will become plus. So if power is plus, convex lens. If power is minus, that is concave lens. Okay, now let us see here. What sign is given? Minus. So you can say directly it is a type of lens is concave. But he is asking to find the focal length also. So focal length is equals to -1 divided by 2. 1 by 2 means half. Therefore, F is equals to -0.5. This is the focal length. Okay. Now let us see the next question. 16th question. Okay, -0.5. Okay, and one more. Here units are not given. So what to do? Power. The focal length is always measured in meters. So answer will be -0.5 meters. Okay, this is the focal length. And which type of a lens it is? Minus concave lens. Understood? Next, last question. Note down. I hope you have understood it. The last question is, a doctor has prescribed a corrective lens of power. Again, power is given, P is equals to plus 1.5 D plus which lens? Convex lens. Find the focal length of the lens. Is the prescribed lens is diverging or converging? I told you converging convex lens is also known as converging lens. So, and diverging lens, concave lens. He is asking which is either it is a concave or convex. Instead of giving concave and convex, he has mentioned diverging or converging. Okay, so power, find the focal length. Formula again, F is equals to, we need to find it. What is the formula? Power is equals to 1 divided by F. So F is equals to 1 divided by power. Power value I will write here 1.5. Okay, so 1.5 again. To simplify it, F is equals to, I will write 10 divided by 15. How? 1 divided by 1.5 can be written as 15 by 10. So by 10 if it goes up, it will become 15 by 10. So 5 2s are 10, 5 3s are 15. Okay. Now just divide here 3 and 2. 0.0. 3 6 are 18. 2.36 are again 18. 2 again 3 6 are 18. So I'll not take much. Okay, I'll just conclude here. F is equals to 0.66 meters. And what is the sign here? Plus. So which lens is advised by the or prescribed by the doctor? It is converging or convex lens. Convex lens. Okay, diverging means concave lens. Okay, understood? So the answer is f is equals to 0.66 meters. Therefore, the doctor has prescribed the convex lens to the person. Okay, so this is also one. This is an important point that you should remember. Okay, and if you want, you can convert it into centimeter also. So this is all about the numericals which are given in page number, which is given in NCERT last exercise problems. Any doubts if you have, you can just mention in a comment box. Okay, and I'll explain the whatever the queries or whatever the problems that you have. Okay, so please follow all the videos, then you will understand the concepts, the numericals, the sign conventions, ray diagrams. Okay, very easy, very simple, which are very helpful, which are very important in the board exam. Okay, with this, the chapter physics, first chapter, reflection of light, reflection and refraction of light is completed. Okay, thank you. Let us meet in the next video with a new chapter, human eye and colorful world. Okay, thank you.